अरे अरे good good evening students. We have to discuss about conductancy 2. We already discussed conductancy 1. In conductancy 1 we know the equivalent conductance, molar conductance, etc. and its conductancy, conductivity, and the Walden rule and other rules, Wien's rule. These are things, but in conductancy 2, I already sent you the PDF note of this. We have to discuss here something about conductancy 2. In conductancy means we have to consider an electrolyte. We have to consider an electrolyte. In electrolyte, when we put it in water, it is converted into ions. That depends upon the splitting of the ions, depends upon the type of electrolyte. So basically the electrolyte consists of two types. One is strong electrolyte, another is weak electrolyte. Strong electrolyte, we know that it undergo 100% ionization, but weak electrolyte is not less than 100%. Mainly those are which are called below 10% ionization, they are called as the weak electrolyte. In case of strong electrolyte, the ions are completely ionized, like sodium chloride, potassium chloride, these are completely ionized. In case of weak electrolyte, these are not completely ionized, they are partially ionized. So these are called all organic acids, acetic acid, hydrogen cyanide, carbonic acid, phosphorus acid. These are all are the ammonium hydroxide if you consider. Then these are called as the weak electrolyte. So in these cases, what we do now, we have to know that these are when the electrolyte dissolved in water, it is converted into ions. The ions are two types. One is cation, another is anion. Cation is positive charge, anion is negatively charged. Both the ions can contribute to the conductancy of an electrolyte. It can conductance of the electrolyte. The conductance of the electrolyte depends upon the mobility of the two ions, the mobility of the cation and mobility of the anions. So this mobility of the cation and mobility of the anion depends upon the applied electric field. Electric field, which is also called as electrostatic field. Electrostatic field. That means we take a beaker, we take sodium chloride solution, two electrodes we have to put, one is anode, one is cathode. Normally left side is anode, right side is cathode. When we apply a potential difference is created, that means electric field is generated. The cation and anion starts to move with each other, and while they are moving, they conduct electric current. This is the main thing. So that means we have to apply electrostatic field. Electric field, why we apply? To make the potential difference between the two electrodes, anode and cathode. If the potential difference will be more, the cation and anion moves with very fast. If the potential difference is less, the cation anion moves is very slow. We already know this one in Wien effect and the Falkenhagen effect. We know that how the frequency and electric potential affect the conductancy of the ions. So in that cases, what we know now, when they are in movement and carry the electric current, that here in case of electric wire, electron is the carrier. In this case, ions are the carrier. So in that cases, we can know how the ions are moved. In that purpose, we consider ionic velocity. Ionic velocity is the speed obtained by an ion in an electrolytic medium. this is the medium is sodium chloride solution. The cation anion starts to move with each other in an electrolytic medium. In an electrolytic medium, under the applied electric field, in an applied externally applied electric field, we have to apply it. But condition is that electric field should be uniform throughout the medium. Here what we consider medium means, we take here water, 5 gram of sodium chloride we put, and the sodium chloride is strong electrolyte. It is converted into Na plus and Cl minus. Both the ions starts to move towards their respective electrodes. That means cation moves towards the cathode, anion moves towards the anode. While they are moving, they carry the electric current. This is called conductancy. But if we apply the electric field from the externally, when that electric field application means we create potential difference between the two electrodes. When the potential difference is created, the ion starts to move towards each other. The cation moves towards cathode, anion moves towards the anode. So the speed with which the ions are moved, towards the respective electrodes is called as the ionic velocity. Ionic velocity, it is also called as the drift velocity. It is also called as drift velocity. Condition is that the electric field applied should be uniform throughout the solution. Then this is, but what is the formula? Now Vd is equal to mu into E. Vd is called drift velocity or ionic velocity. Ionic velocity means the speed with which the ions move. Mu is the ionic mobility. I will tell you after this what is the ionic mobility. E is the magnitude of the applied electric field. This is called the ionic velocity. What is the unit? Now unit is meter per second is the unit of ionic velocity. Then consider ionic mobility. Ionic mobility means the ability of the ion. Mobility means the ability of the ions to move through the medium, upon the unit electric field, upon the unit of the unit applied electric field. This is called ionic mobility. Difference is that ionic velocity will tells you the speed of the ion, and ionic mobility tells you the ability of the ion. What is the difference is that speed means, suppose we consider that this is one of the two poles is there. Here is the left pole, here is the right pole. Suppose any person, suppose you consider that you itself moves from here, you are here, you moves to right direction and also you moves to the left direction. If I want to tell you what is the speed of you, now distance between the two poles divided by time taken. Suppose distance is 10 meter and time taken is suppose 5 seconds. Then what is the speed? Now 10 by 5, it is meter per second. This is the speed, but this is called the speed. Similarly, consider that you itself a ion. So when the ion moves from left to right, what is the distance covered? Divided by time, that is called ionic velocity, but drift velocity. But what is the ionic mobility? Ionic mobility means the ability of the ion to move towards the between the two poles. Suppose I tell that you itself here, I give you 5 kg of rice. Then what is your ability to move from left or move from right? What is the ability? Suppose again after 5 kg, I supply you 10 kg, whether you move or not, you start to move left to right. Again I give you 15 kg, you start to move here and there, but velocity will be gradually decreases. In case of 5 kg, suppose in case of 5 kg, you move slowly. Suppose in case of 0 kg, you move fast. But in case of 5 kg, you move slow. Again 10 kg, again slow. Again 15 kg, again you start to move slow. If I give 50 kg, you may not be able to move left and right because it is not your ability. You cannot have, you do not have ability to carry 50 kg of bags. That is why your ability suppose 15 kg. That means you load 15 kg and you move from left to right. That was called the ionic mobility. Ionic mobility means ability, and ionic speed means velocity means what is the speed. This is the difference between the mobility and the speed. But mobility formula is mu, same thing, Vd by E. Vd is the ionic velocity, E is the electric field. That Vd electric field means voltage. Voltage means potential difference divided by distance. Voltage by distance. What is the unit? If you ask me, ionic velocity unit is meter per second divided by voltage unit is volt divided by distance is measured in SI system is meter. When it comes that meter by second into meter by voltage, that means what you get? Now meter square volt inverse second inverse. This is the SI unit of ionic mobility. But what is the SI unit of ionic velocity? Is meter per second. In case of mobility, meter square, voltage inverse, second inverse. Voltage means it is potential difference. Suppose in your home, now in our, according to our Supreme Court order, we should have 240 volt. Before 10 or 15 years back, we get 230 volt. We get now 240 volt. So 240 volt means 240 volt means this is the potential difference between one pole to another pole. Suppose this is your home and where this is the current. Suppose it is the current where it is stored and this is your home. So here is the current, it is stored, but here there is no current. So if I create potential difference, then the current, but that means the electron starts to move from this pole to this pole because potential difference is created. Similarly, consider that in case of your fan. Fan, we put a capacitor. Capacitor different types, air capacitor, oil capacitor, also different types of other capacitors are available. Nowadays, super capacitor also now available. Suppose you remove the capacitor from your fan. Can the fan move? Not possible. Moves, but very slowly. So capacitor, when it is becomes weak, means potential difference created between them is weak. When potential difference weak means the current flow will be slow. So in that potential capacitor, what is the capacitor uses is that it creates potential difference between the two ends. So as a result, the electric current will flow. So this is the same thing happen what is called voltage. Voltage means it is potential difference. So voltage unit is voltage, distance is meter. When you come to this is the unit of ionic mobility. This is the SI unit of ionic velocity. Now this is what the difference between the ionic mobility and ionic velocity. One is the unit. In case of SI unit, ionic mobility is meter square, voltage inverse, second inverse, and ionic velocity is meter and second inverse. Another is ionic mobility will tells you the ability of the ion, and another ionic velocity means what is the speed of the ion. In both cases, the electric field is uniform. If the electric field is different, it is not applicable. Uniform electric field is applied in the electrolytic solution. Then we come across the determination, how we determine determination of ionic mobility and ionic velocity. how we determine experimentally, how we determine ionic mobility and ionic velocity. How we determine? For that purpose, what we do? Now we take a uniform bore tube. In the uniform bore tube, in the lower end, what we put? Now it is called anode side, and here is the platinum electrode. In the upper end, this is cathode. We put here cathode. It is also contain platinum electrode. Both are platinum. It is platinum. It is also platinum electrode. Now it is connect, and this is a uniform bore tube, and it is the platinum electrode. It is also platinum electrode. Lower end is anode. Upper end is cathode. So cathode is in case of anion moves towards anode, cation moves towards cathode. When anion moves towards anode, it loses electron. When it loses electron, it moves through the external circuit. Cation moves towards cathode and gain electrons. So in that cases, both are anode and cathode. This cathode and this anode is connected to a potential difference. Here small, large. Then we have to put here. Then we put here, there is a bar like this is called rheostat. Rheostat means it creates potential difference larger and higher. Nowadays the electronic rheostat is available, but in the previous in our time, that means when our schooling time, we use the rheostat means we have to contain a ebonite rod such type. You can also prepare ebonite rod such types, and in that cases the wire is wound, in the wire is wound over it, copper wire or aluminum wire depending upon that cost, and there is a slider will be there, and the slider moves left and right, then potential difference starts to create. Nowadays rheostat means no one use this one, we all are used as the electronic rheostat is available nowadays. Anywhere you go, mobile or anything else, we use the electronic rheostat. Nowadays these are not available, but these can be placed in the laboratory also in some cases. But electronic rheostat is more powerful. This one, it is a very long and very massive substance, but electronic rheostat is only few milligrams. So this is the difference, but same function. It creates potential difference. Here it creates potential difference between the two electrodes. Suppose we want to find out what is the ionic mobility of potassium plus. Potassium is cation. For that purpose, suppose we take potassium chloride as the electrolyte, and we here put a visible boundary, and in the anode side we put cadmium chloride, and in the cathode side potassium chloride, anode side is cadmium chloride, and it is a visible boundary. Potassium chloride is colorless and cadmium chloride also colorless. Both are colorless, so we cannot distinguish where they move. So in their cases, in separate, first we put cadmium chloride, then put a visible boundary. Whatever friction should be as minimum as possible. So it is a visible boundary we have to put. Otherwise we cannot know how far they will move. So it is a visible boundary. It is cadmium chloride. Upper one is potassium chloride. I want to find out what is the ionic mobility of potassium ion, and what is its speed also, and its ionic velocity, I want to find out, which is known as drift velocity. So I want to find out ionic mobility and ionic velocity of potassium ion. For that purpose, we take potassium chloride is one electrolyte. It is strong electrolyte. So potassium chloride here, it is called as principal electrolyte. It is a principal electrolyte. And cadmium, that means when you put potassium chloride in water, it is 100% ionization, K plus Cl minus. It is converted. Now, then how you choose another electrolyte? While choosing the another electrolyte, you have to keep in mind that whatever be the anion of the principal electrolyte, we want to find out the ionic mobility of potassium ion, and ionic velocity of potassium ion. For that purpose, I will take potassium chloride as the principal electrolyte. So remember, while you choosing the indicator electrolyte, this is called indicator. This is called principal electrolyte, whose ionic mobility, one of the ion we can find out, principal, PRINCI, principal electrolyte. This is called indicator electrolyte. That means the anion of the principal electrolyte should be same as that of the indicator electrolyte. While choosing the indicator electrolyte, you have to keep in mind that the anion of the principal electrolyte should be same as that of the indicator electrolyte. First thing. Second thing, the mobility of the principal electrolyte, whose ionic mobility I want to find out. The mobility of the indicator electrolyte should be less than that of the principal electrolyte. So for this purpose, potassium chloride as principal electrolyte, I want to find out ionic mobility of potassium ion. We have to take cadmium chloride as the indicator electrolyte. Potassium chloride is colorless solution, cadmium chloride also colorless. So in between, in order to identify the movement, we have to put a visible boundary in between the two electrolytic solutions, so that the two electrolytic solutions are not mixed. So in that cases, in the anode side cadmium chloride, cathode side is potassium chloride. Now what we apply? Now when we apply the electric current means we have to do not apply, create potential difference between the two electrodes. Here is cathode, here is anode. When we create potential difference, what happens? Now all the cations, cadmium chloride also converted cadmium 2 plus 2Cl minus. Potassium chloride converted K plus Cl minus. We know that cation moves towards cathode, anion moves towards the anode. So when potassium K plus moves towards the cathode and cadmium 2 plus also moves towards the cathode. So while potassium plus ion moves very fast, cadmium chloride moves slowly, because mobility should we choose such type of indicator electrolyte which mobility will be less. Now the potassium ion moves towards the cathode and cadmium also starts to move towards the upward. When the cadmium starts to move upward, this visible boundary, where suppose I put it name the position is x1. Suppose after some time, when create potential difference, cation moves towards cathode, anion moves towards the anode. When cation moves towards cathode, the K plus moves upward, cadmium plus slowly moves upward. When both are moving, potassium moving cathode, while cadmium moving cathode, the visible boundary shift from x1 to x2, because cadmium moves upward, potassium moves upward. So when it moves upward, it is in your mind, anion moves towards anode, but both anion are same. So both, that means the mobility of this chlorine and the mobility of this chlorine will be same, no difference. But in this case, what happens? Now mobility of potassium is more and mobility of cadmium is less. So when potassium moves upward, cadmium moves upward, the visible boundary moves from x1 to x2. Suppose this time it takes t second. That means, what is my ionic velocity? If anyone asked me what is the ionic velocity of potassium, now ionic velocity is what? Now distance covered. How distance? Now upper one minus lower one, x2 minus x1 divided by time taken. Suppose this distance is 5 centimeter. This distance is 5 centimeter. Suppose time taken is 50 seconds. Time taken, suppose distance between x1 and x2 is 5 centimeter and time taken is suppose 50 seconds. Then how you find out the ionic velocity? Remember that you always convert into SI system, never kept in SI system. You have to convert 5 centimeter into meter. 1 meter is equal to 100 centimeter. So 1 meter is equal to 100 centimeter. Then how the 5 centimeter? Now 5 by 100. That means 0.05 is the meter. That means this meter it is covered. What is the time taken? 50 seconds. Then what is my ionic velocity? Now the ionic velocity is 0.05 divided by 50. This is called meter per second. This is, we can measure the ionic velocity. But how we measure the ionic mobility? Now the ionic mobility, we can measure drift velocity by ionic velocity divided by what is the potential difference we created, that is called potential gradient, which is called as the Z. We consider Z is the potential gradient and V is the ionic mobility of the potential gradient and the ionic velocity. So in the cases, potential difference, suppose whatever you created, suppose Z is the potential gradient we created, then what is the ionic mobility? Now ionic mobility is Vd, means this is the meter per second ionic velocity. Ionic velocity है मोर 0.05 divided by 50 second divided by potential gradient. Potential gradient, something you created, suppose 230 volt. 230 volt you created, 230 volt you created means potential gradient you created. How you determine what is the current flow, what is the potential gradient? For that purpose, if this battery is unknown, we do not know. If the battery is there, then it is easy for us to calculate the potential gradient. If the battery is not known, then we have to connect parallelly to this to a copper calorimeter. That means this solution you have to get. Here is the two electrode you have to get, and copper sulfate solution, suppose you have to take copper sulfate solution. You do not know what is the amount of current here pass. For that purpose, we have to connect this to this with a copper calorimeter. Copper sulfate you take, then electric current is passed. Whatever be the amount of copper sulfate means it converted copper to plus sulfate to minus. Copper cation moves towards cathode. Copper moves towards the cathode, anion moves towards the anode. So copper is deposited at the cathode. When copper is deposited means whatever is the amount of copper deposited, suppose the atomic weight of copper is 63.5 gram. We know that according to the Faraday law, you already know in plus 2, 96,500 coulomb. That means 1 Faraday electricity when we pass in copper sulfate, equivalent weight of copper is deposited. What is the equivalent weight of copper? The equivalent weight of copper is atomic weight of copper divided by valency is 2, which is equal to 31.75 gram. This much amount of copper. That means 96,500 coulomb will deposit 31.75 gram of copper. Now you have to pass electric current here. Copper is deposited in the cathode. What is the copper amount is copper deposited? From that you can know what amount of current you flow through it. That means 31.75 gram of copper is deposited, 96,500 coulomb. Then 1 gram copper deposited, 96,500 divided by 31.75 coulomb. Whatever be the amount copper deposited in the duration of 50 seconds, because in 50 seconds this x1 moves towards the x2. In 50 seconds, what is the amount of copper deposited? You have to wait this, what is the amount copper deposited, multiply with this amount, and you get amount of current is passed through this parallel tube. And from that you can also know that what is the potential gradient of this if it is unknown. If it is known, because it is a rheostat, we have to change its potential by any means, left and right, moving here and there, left and right, then we can potential change. If we know the potential gradient, then there is no need to use the copper calorimeter. If it is unknown, then you can use copper calorimeter or silver calorimeter. Anything else you can use it. So in that cases, then what is the potential gradient is created? Now ionic mobility is 0.05 divided by 50 divided by Z, potential gradient. What is the potential gradient you apply? This is called the ionic mobility of the potassium ion, and from this experiment using parallel tube method we can calculate ionic velocity and ionic mobility of the principal electrolyte cation. In the same way also you can find out anion. Suppose I want to find out the principal electrolyte of the anion, chlorine, ionic velocity and ionic mobility. But condition should be that the cation of the principal electrolyte should be same as that of the indicator electrolyte. If I want to find out the ionic mobility of the anion instead of cation, if I want to find out the ionic mobility of the anion instead of cation, then the cation of principal electrolyte should be same as that of the indicator electrolyte. Then only we can measure the ionic mobility and ionic velocity of the anion. So in this way we can determine the ionic velocity and ionic mobility of the of that of the any cation and any of the anion. Then next we have to talk about the transport number. Transport number means time okay. Khuda Hafiz, Khuda Hafiz. We end here now. So we see.